Okay. Hi, Victor is here. Next 14 has been out for a few days, and I thought it might be a good idea to record a walkthrough showing you how to, how to add an X to an existing monorepo. How easy it is, what kind of benefits you get, how it works, etc. And also talk a little bit about what's changed, in the last 6 months, in the last year. Just show you what's going on, basically. Right? And I tend to get feedback when I record such walkthroughs is that they're very fast and a very high pace, and very intense because I tend to be an intense person, right? So I thought about how to address this, how to make it less intense. And the thing that I came up with is if I record it later in the day, basically at night, perhaps I'll be tired enough where it's not going to be as crazy fast paced, right? So that's what I'm trying to do today, and we'll see how it goes. Okay, so what I have in here is a monorepo, a Yarn workspaces monorepo, right? It has 3 packages. There is a components library, there is a NextJS application, and there is a remix application, right? The component library is very simple. There is just one component called header, right, that I'm going to use in the 2 applications, right? And in my application, in the Next.js application, I'm importing this component, and I'm just going to use it, right? So don't worry about how the legitimacy of this application or this particular component. We're not interested in what this application is doing right now. We'll look at the monorepo aspect of it. There is a package called components, and there is another package called next app that depends on components like this. Right? And there is a remix app, again, very similarly set up, right? It doesn't have a lot going on. There is a route, and if I go into the route, I will see that again it imports the same component, the same header component from the components library, and it then uses it on the page. Right? So there is not much going on. It's actually very simple. If I go to, say, a remix app, and I do yarn dev, right? Let me open it up. So this is my application. As you can see, it is working, right? So that's what I have. Super basic. Not much is going on. The Next.js app will do the same. So if I want to add an X to this monorepo, what I need to do is I need to run a command called add an X to monorepo. Do you have to use this command? No, you don't have to, right? You will see what it does. It does very little, right? And you can do it by hand, right? You don't have to run this command. It just helps you do a few things, do a few things for you, right? While we're waiting, okay, there are some instructions on what to do in there. Let's just ignore it for now. It just doesn't matter. I want to show you what has changed. All right. So firstly, the package.json has changed. We've added 2 dependencies to the package.json, the Next package itself, which is basically the core of an X. It's sort of a language agnostic CLI with distribution, caching, and all that jazz, right? When folks think about an X, the core of running commands and stuff, that's what they think about. And there is also an X cloud over here. The cloud bit allows you to use distributed caching, distributed task execution, things like that. And it's absolutely optional, right? You can implement your own versions of all of this, right? We believe in pluggability all the way through. So in this case, that's why it's a separate package, right? Okay. The next thing, it added an Next.json. Let me open it like this, right? Next.json is the configuration file that tells the next CLI how to run, right? And it contains project-independent information, things that are just general about the CLI, right? It's kind of hard to guess well about how it needs to be configured for any given repo, so this is our attempt to do it. For example, in here, we have this cacheable operations, some common thing that you tend to see. Let's say we only care about these 2. Here, we configure target dependencies. And in an X, different targets, like build can depend on builds, or test can depend on builds. Like you can define a graph of targets. I will show you a bit in a second, right? And you can sort of establish invariants. And you can say, oh, before I build my project, I want my dependencies to be built, for example, will be an invariant. And then next, when you run a build command on a given project, we'll make sure that either it will build the dependencies of that command first, or that it's able to restore them from cache, for example, right? If you or someone else have built those exact versions of those dependencies, or what's even better, if those dependencies have already been built on your machine or restored from cache and placed in the right places, right? The outputs are there, it will just do nothing. Okay? And I'll show you more as we move along, but it's basically an invariant saying before you build anything, make sure dependencies are built. Right? And in this case, one extra bit I want to show you is we need to know the base branch from which we calculate what's been affected by your PR. We deduced, or that at the next Monorepo script deduced that your main branch is called main. You can change it in here. You can also main is also the default, so I can remove it. Right? So that's what I have right now. That's the whole step-like configuration. It's pretty basic. There's not much going on. The second thing we need to do is we need to tell Next, right, where some outputs, where file artifacts basically will be created. Right? And the way you do it is you create a property called Next in package.json of every project. Right? And in this case, you can define another property called targets. And you can say, well, for the build, I want my outputs to be, and this is the next tab. You can say packages next app.next, for example. Right? So what this is telling Next is when you run build, right? This is what the files are going to be created. So after the command runs, Next is going to look at that folder, basically zip it up, store it elsewhere. So next time you run build of the same project, Next will check, hey, have I built this exact version of the next app with dependencies and stuff, right? And if it did, it's going to restore it it's going to basically put the files in this folder, right? So we have this. That looks fine. So let's open the Remix app and configure something similar. And in here, let's say we call the cache or something, and then and just for your information, there is a way to draw it up to make it, so you don't have to configure it like this, etc. But this is the simplest way to get started, right? You're basically saying I have the Next CLI configured here, and I have my sort of projects augmented by using this Next property in package.json, right? So with this in place, right, I should be good to go. That actually should be sufficient for me to start running Next commands, which I could do right now. Let's say I want to build all the projects. If I do this, you'll see that it's going to build components first, and then it's going to build the Remix and Next tabs. By the way, Remix and Next tabs I invoked at the same time, right? So the components have to be built first, and I'll show you why, right? The Remix tab and Next tab have to build at the same time. It's just the Next tab took a bit longer to build, right? But they want to run sequentially. You can change it if I pass, let's say, parallel equals 1, it would run everything sequentially. But by default, it runs it in a topological order, where your dependencies are processed first before you can process yourself. Right? At a side note, it doesn't mean that if you have a dependency between projects, that all the tasks will follow it. For example, if you run like jest specs, most of the time you don't need to run them in a particular order, right? So you can have in this case, Next tab depending on the component, but they can be tested at the same time, for example. Right? Okay, so anywho, so I can do it again, right? As you can see, I run it again, and it tells me, what it tells me is that, hey, I don't need to do anything. So it computed some hash, figured out that you're doing the exact same thing, right? And just left the outputs as is. So it doesn't remove files and put them back, right? That's what Next is good at. It basically does a 3D thing of your outputs and only modify the things that have changed, which allows it to be much faster, but also integrates nicer in the workflows where you actually want to watch the outputs, right? Which is not uncommon, right? And now what I can do, let's note in this Remix app folder, I'm going to remove this build thing, right? It's gone. Right, again, the build is back, right? But I want you to know the output reflected this, right? For components and next step, the output will left in the right place, right? And for the remix app, it's a retrieved from local cache. Right? Okay, so that's one small thing. I will show you one cool thing. So you can see right now when I'm running all of the things, the outputs are not. I don't see anything, right? I don't see the outputs being displayed, right? And the outputs aren't being displayed because by default, when you run things locally, so we can tell when you have the right terminal that that's not a CI environment. When you run things in non-CI environments, we only show things when they fail, right? If I break this components library, I will see it. I will see the full logs right here. Right? Also, if I click on this button, by the way, right, you will see this is dark mode. Let me turn it off. That the logs are there. So the logs are there. They are captured, right? It's just we don't show them because you don't care about them. Everything is good. Sometimes you run this command against 200 projects. You don't want to see anything, right? However, on CI, we usually do things like this, right? This basically what CI, oops, it tells me to sleep, not right now. And what CI will do. And if you do this, you will see the output fully printed out, right? The output is captured regardless. So you can always get access to it. It's just, we hide it for the dev ergonomics case, right? Another thing I want to point out is that if I actually skip the cache, let me show you right now, right? And I run the same command, you'll see an important thing, which is a big deal, right? And what we care about deeply is that the remix and NextJS outputs are grouped. Right? They run in parallel, but the way we do it by default, right, is we group the output for every project such that it's all together. So we wait for the process to complete, if it's a completable process, not like a serve. And once it's complete, we capture the output, cache it, and print it out, right? Instead of printing it as it goes, right? When you do a run many-like command. Because, again, if you're running 50 things, especially if you run them on CI, you don't want to see output all interleaved, because it's impossible to understand what's going on. Right? Okay, so let me show you one more thing. Right? If I do a next reset is going to remove my local cache. No more local cache left. We run this again. Actually, let me just remove this guy because it's not important, right? So look, again, I run this command. Look, everything was retrieved from cache, from a remote cache in this case, right? Because I enabled cloud in here. And this is, by default, the cloud comes with a read-write token, so you can read and write into the cache. I don't necessarily recommend it for large projects. In this case, on large projects, I think CI should write, but local developers should only read from cache, but not write to it, but separate point, right? And as you can see, the cloud was able to find the same artifacts. Like if I was a different developer right now running the same command, I would get everything from cache, right? Which this message makes it pretty clear. Okay, well, let me show you something else, okay? So now, let me build the remix app. So we have this remix app, right? Any NPM scripts I see, you will see it over here. There are a bunch of NPM scripts. Any scripts I can run with an X run remix app build. That will be the name of the script. And whatever flags I pass into this command will be passed to the NPM script, right? Pretty straightforward. Because it's so common, right? We support the syntax, we can do this, right? In general, one of the things that we did and try to do well is we try to optimize for the commonly ran things when it comes to the CLI experience, right? Most of the time, you only run one thing. You don't run, 2,000 things or whatever, right? So because you run one thing, that command is shorter than running many things, than doing run many. Right? This is the most common use case. You run this 1,000 times more frequently than you run many. Because that's why it's shorter. It's as short as it can be. Okay, let me do it. Okay, cool. Now this has worked. I can run it again. Okay, it works again. Right? Note the following. There are two things to note. Firstly, it prints the thing. It tells me that in addition to building the remix app, there is another task that had to happen. That task is the components build, right? If I click on this thing, you will see it, right? I run the remix build, but there are actually two things happen. The components build happens, and then the remix build, which is the components build in this case, the result is already left in the right place, so it was free, essentially. But that's a big difference of how Next thinks about utils graphs comparing to some other tools, is that when we see things like this, right, that's not a way for us to tell the task runner, or just do this in the right order, right? It's not imperative. This is a declarative invariant, meaning we are saying that to build remix app, all the dependencies, the results of building the dependencies have to be in the right place. If they're already there, fantastic, don't do anything. If they're not there, but you find them in cache, or get them from the cache. If they're not in a cache, you have to build them, right? You cannot skip this process because that's an invariant. It's a guarantee that the process that builds the remix app can be certain that the files of all the dependencies, the dists, the outputs are in the right place. They cannot not be there, right? That's the guarantee. You cannot skip it, and it's a big deal. It's by design, and it's, believe me, that property that it's an invariant as an instruction saying build with dependencies, without dependencies, do this scope, that scope. This is much better. Right, in a role, it results in a much more predictable way of doing things. Right? Let me change my header. I do this, right? And I run this again. You'll see it waits a bit because it needs to rebuild the remix app, and then it rebuilds the app, and here we go. Right? It all worked again, and it wasn't right from cache this time. Right? And if I do it again, boom, it's fast. A few small things. So most of the time, this check, this invariant that we have, is free or it's very fast because Next is much better at deducing what should be restored from cache or whatever than other tools. So it's usually like fairly instant. I'm going to show you why. And so it doesn't cost anything to do the right thing. Right? We don't have to put this weight on the developer. We just know. A second thing to note is that when you're building one thing, we always show the logs in here. All right, like we don't hide it as in run many because if I'm building the remix app, I'm actually interested in the remix app, so I want to see the logs. I'll show you something. If I do something like I don't know, something like that, right? You'll see something that's a bit different. Oh, it will tell me that the component failed to build and will give me an error. Right, so that happened, and in this case, it wasn't able to build the remix app because the precondition failed. Just undo it, okay? And if I do it again, boom, retrieve from cache, super fast. And okay, so that works, right? Let me actually show you one thing that I perhaps wasn't clear. So if I open any of these links, right, and I see, I don't know, let's say I make a change and I do something like this. Actually, this is a weird change. Header, right? And I run it. You'll see it's going to be 2 cache misses now, right? Now let me examine this output for Nextcloud. This is a cache miss, right? Cache miss, the new thing, haven't seen it before. I can compare it to other runs, to other builds of other builds of components that have happened, and the idea in there. Let me let's say I'm gonna pick this. Is that it allows me to troubleshoot. Again, let me turn off dark mode for 1 second. Right, troubleshoot cache misses. Okay, in this case, it's a trivial example. Right, it basically tells me that the component's source have changed. I see the hash is different, probably the culprit, right? But if you imagine this being a lot more complex with, I don't know, 10,000 nodes, some runtime values, implicit depths, this actually is much handy because I can simply say, hey, show me what's different. You look at it like, aha, right? What's different is, that runtime value. So why does it matter, right? Without this tool, if you imagine having, say, a cache miss on CI, and you're like, a particular run should have been a cache hit, but it's not. It just isn't. Right? It's not a cache hit. You're looking at it. The problem is that if you now rerun the same CI run, right? You push, like restart it or whatever, it will be a cache hit because rerunning will result in the same hash output, and it will very likely be a cache hit. So you won't be able to troubleshoot it. This is a problem because rerunning will make everything a cache hit. So you cannot really troubleshoot cache misses easily on CI. In here you can, because Nextcloud records all this extra stuff about your commands, like this metadata, like this basically this document. So when you have a cache miss, you can say, "Oh, let me compare to the things where it was close enough, and I think it should be a hit." You can compare and like, "Oh, I see, this file keeps changing. Interesting. Why is it changing? Maybe my CI process changes it. Right? No good. Let me fix it. Some deployment step or something like that." Right? So you have to have this information captured and available to you. You cannot achieve it by enabling some verbose logs and running CI, because the act of enabling verbose logs might invalidate the cache. Rerunning the CI will always put stuff into the cache. So like you're dealing with basically a system where anything affects this mutable store of what's stored in the cache, right? So the only way for you to really debug it is to store metadata about every single thing you do in there, such that when you need to figure out what's wrong, you have access to that metadata, ideally in the UI as I showed you. Right? Much more important than it seems. Believe me, we didn't have it at the beginning, and troubleshooting cache miss was a nightmare. All right? Okay, so let me show you something else. Okay, so that's let me actually check it in. Okay, that is good enough. I'm making good progress. Right? So if I do something like this now, target build, what's going to happen is like no projects have changed since main, so nothing is going to be rebuilt, right? If I change blah, 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 something in there. It doesn't matter what it is. I make a change, right? And I do the same. Well, as you can see, remix app is going to be built. The component actually wasn't affected, but we have to build it for the remix app to be built. Again, invariance, remember? And next is all about invariance. It's not an imperative system where you tell, well, build that, and don't forget about this. You define invariance, and then everything just works, right? So that's the affected part, where you're basically saying, look at everything that my PR, let's say this is a PR, affects. In this case, it's a single file, and look at where it fits in the graph, figure out where it fits in the graph, right? And rebuild what's necessary, right? And I'll show you much cooler things in a second. All right, so that's the idea. And we do it more intelligently. We look at the nature of the change. If you change a JSON file, we kind of know what parts of the JSON file, what can it affect, etc. So, but the core idea that we look at the change, the nature of the change, figure out what parts of the graph could be affected, and then we essentially, use the invariance to traverse down in the graph to do the things required, and then traverse up to see what can be affected. Right? Okay, cool. So let's go further. And look at another cool feature on X. Actually, let me use, the only reason by the way I'm using VS Code is to show you the NX plugin that is very cool and you should be using if you're using VS Code. I don't normally use VS Code. That's why I'm a bit clumsy with the editor, right? But because everyone does, I'm using what, I'm a man of the people, right? Whatever everyone wants to use, I'm going to use for the demos, right? So I'm going to click on the button called depgraph, which simply invokes the depgraph command. And what I will see in here is, it's actually quite cool, right? So I have a depgraph over here. There are 3 nodes. There is a next app, remix app, and components. This is very basic because the repo is so basic. Let me show you actually, I'm more interested in the repo. Let me, perhaps, let's see. Okay. This is an X repo itself. So an X is built with an X. We strongly believe in dog fooding. If you want to make something useful, use it yourself. So we use an X everywhere. And this is the depth graph for, whoa, let me make it full screen-ish, for an X. A bit scary, but it's good, believe me. this is what you want, right? So let me group it by directory. Okay, it's a bit better now. As you can see, our next repo has a bunch of packages that were published to npm, a bunch of end-to-end tests, a lot of end-to-end tests actually. And the next dev is a website. You know that if you go to a next dev, this website, right, is over here. It's all in the same Monorepo. Okay, so let's zoom in here and see what we can do with this graph. Right, this dev graph is so cool, right? Like there is nothing even remotely as cool as what we see in here in other systems, right? So I want you to appreciate the coolness of this graph, right? So what I can do in here, for example, I can click on detox and say, let's focus. And I could see, and I can disable this, right? This is everything that the detox package, how it participates in the graph, right? You can see everything it depends on, everything that depends on it. And I can activate proximity, for example, to make it less, to only look at the sort of one level deep dependencies, right, in either direction. It's a bit easier. And I can do other things. If I click over here, right, you can see I can do start and end, which means that I can pick a package one, pick a different package, and it matters in workspace if you say 1,000 packages, which is not uncommon with NX. A lot of NX workspaces are big. And I could say, I have this app and this weird lib over here. How do they depend on each other? And it can show you either one version or everything, right? Which is quite amazing that what you can do in here, right? And so that, I actually show you now. Start, end, right? And it depends directly, right? And I can also show you all different ways in which detox depend on it. So it depends on the workspace package, but also it depends on it through all these other packages. So even if I remove this dependency, the direct dependency, the issue, like the dependency will still be there transitively, right? So this is my dependency. In this graph, if I click on any edge in this graph, what I'm going to see is a list of files that participated, right, that inform this edge, right? Meaning that the detox package depends on the workspace package in its package.json, and it's a bunch of TypeScript files, right? This is amazing for figuring out, and I will show you why it matters, right? For figuring out why, like, for example, a circular dependency is present. You're like, why do those things depend on each other? And you're like, oh, I see why. Through this investigative work where you can just click on things, you can see how everything comes together, right? Why the graph is the way it is. Right? It's a much bigger deal than it seems. I just okay. So why does it matter, and why? Like, so I showed you the graph. I think it's pretty cool, right? So, but I want to show you, explain one thing that is of importance in here, and what makes NX so much more special, right? Than some other tools, right? So the command I ran, I've added this, right, to my next.json, and basically what it does is, by default, NX has two properties called package.json, right? So, and so what it does essentially. This property, and by default, both of them are true, right? If I look at package.json, this property determines whether NX is going to look at, say, this file, right? Find things like this and draw edges in those graphs, right? This, in this case, this package.json file informs NX about the dependency. What NX can also do, it can analyze source files. So if I have, I don't know, this, right? We don't have to have anything in the package.json. We don't have to use Yarn workspace at all to tell that, okay, there is an edge in here. We look at this TSX file, it's clear, right? So if I change it to true, or simply remove it, right? Because that's the default, right? That's what's going to happen. We're going to analyze OTS files. And why this is so important? It allows you to create much more lightweight packages where you don't have to have this package.json files wiring things together using Yarn workspaces or whatnot, right? Yarn workspaces in general is good at some things, but really bad at very many other things. You don't have to do it. It's much more likely. That's why with an X, it's not uncommon to have 1,000 packages in libs in your workspace, because there's a lot less effort to maintain that, right? Compared to Yarn workspace. The Yarn workspace with 1,000 packages is a nightmare. Right? With an X, it's trivial. But secondly, is it allows you to make sure that your graph is correct. Right? So when I go to again to the next graph, let me go to the thing again. Right? When I open this, right, and I see this, and I see this, what I can tell you that this graph is correct. Right? And Next figured out all these edges. I didn't have to tell it. Right? Meaning that I know exactly what detox is, like how it relates to everything else, because that's what it imports in its source. Right? I cannot forget to add a dependency to package.json. I can't, because detox, that dependency would have been discovered in the source file and put in here. So as a result, the graph you see with an X has a much higher chance of being actually correct, that you don't have an edge that you forgot to configure. Again, if you have a workspace with 10 packages, it's easy to configure all the edges. 50, not so easy. 1,000, not possible, right? So it actually does matter to the degree where, if you look at, pretty much any open source project using Yarn workspaces or like Learn or something like that, the graphs are incorrect. Right? We've looked at a bunch of them. Every single one has not configured edges, right? The edges that are there. So those are not expressed explicitly. They are expressed implicitly by a CI process running commands in a particular order, so it just happens to work, right? So the fact that you cannot have an incorrect graph with an asterisk, a lot less likely having a correct graph with an X, because we look at everything, right? At all your source files and stuff. It's a big deal, right? The bigger your workspace gets, the bigger this deal is, right? Really, there are only two ways to do monorepos well. You either do this. You basically look at everything, you analyze it, and then you, just show, okay, this is the correct graph based on like it's inferred by the source code. Or you do something like what Basic does, where you create a sandbox, and the configuration is manual, but if you misconfigure, things do not work, right? What folks do with Yarn workspaces, where there is no sandbox, so things could work, right? But you have to configure it yourself, so most likely you'll do it incorrectly, is not working for large enough graphs, right? It's just not a thing that works well. Okay? So, one thing I want to show you, actually, because we do all this super duper analysis, this is a tiny workspace, it doesn't matter, okay? For anything that is not tiny, things do matter, right? We have to be fast, and we are very fast, right? I will show you in a second, but we are much faster than anything else, pretty much, we are looking at. There are a couple of reasons why we are fast, right? We do cache metadata about your workspace in here, right? Like there is this file where we cache like edges coming from every file, such that when you change files, we only have to re-update a small fraction of them, reanalyze only a small fraction of them. That's one thing that we do, and we also do that in the background. So if I do an x-help, you will see actually a cool thing. Let me just run it again. I think over here, and it's because actually when you run an X, we start a daemon process, and we watch what's happening, and we update basically this file, right, behind the scenes, such that it's always instant. Right? So as a result, we do a lot more analysis in other tools, right? A lot more going on with an X compared to other tools when it comes to analysis, because we believe it has to be this way for you to scale your repo, right? But because of this incrementality, both in terms of writing stuff to disk and using the daemon process to update that stuff behind the scenes, you don't pay any penalty, right, in terms of DX, right? Everything is super duper fast. Okay, so that's it. Let me actually check it in again. Another work in progress. Whoa, a lot of progress has been made. All right, so I'll show you one more thing. So what I showed you so far only uses an X core, basically, right? I had like everything in here is, it's just, it just kind of works, right? So only an X core There is no plugins. I'm still running your npm script, so there is no overhead. Right? For one, like you're not using anything on Next specific in here. Next just wraps everything you use to make it fast, basically, and to enable other things like distribution stuff, which I will show in a second. But you could use plugins, right? So if I go inside here and I say, hey, actually, let me add, all right, something like this. Okay, what I can do now, actually, let me reload this thing because I feel like, oh, is that on terminal? I was like, why is this thing so... Okay, now it makes sense. It shouldn't be instant. It actually should run things, right? But what this allows me to do now, it allows me to use an Next plugin. Let me reload this. I need to reload it for the... There are some issues sometimes with the VS Code plugin. If you create a new, like, add some node modules, right, then it automatically picked up. So just ignore it. By and large, it works really well. And I'm also going to add, by the way, node auto completion. How cool is that? Right? This is our approach to tooling in general. Everything auto completes everywhere. And I'll show you more in a second. Right? So with this, I can create a new library, a JavaScript library, and I could call it shared. And this is a preview, by the way. Nothing's been created yet. I'm just looking at what needs to be created. And I can play around with it. For example, I can choose to have JS sources. I can disable linting if I want to, if I don't believe in linting and stuff like that. If I do this, you will see the lint, yes, lint file is gone in here. But let's say I do want linting. Right? I can also pick a compiler. Is it either TSC or SWC? Pick SWC, it's a bit faster. The type checking is still done with TSC though. Okay, so with this in place, look, what has happened here, right? We have the new package here called shared. By the way, the library itself is not interesting. You know, not much is happening here, but right, we've created this. Okay, 1 second. Let me. This needs to be fixed. Okay, cool. So we've created this file called project.json, and that's a different part of an X that I don't think folks who aren't familiar with an X immediately see the value of, but it's actually a big deal, right? So why is it a big deal? Firstly, we have this sort of recipes for doing things that an X treats exactly the same as your npm script. So this is just to make it clear that it doesn't matter whether you have an npm script or this. The cache and the distribution, other aspects of the core and X goodness work the same way, right? And you can see even this property targets, builds, outputs is the same, right? So it's whether you put in package.json here, it doesn't matter, and X will use in the same fashion. But that's basically like a typed npm script. Now you can think that npm script is like JavaScript, whereas this target and project.json is like TypeScript, right? This auto completion works based on the metadata provided by this package, right? Everything in X is toolable and integrates with the editor. The JS plugin, the SWC function in there, says I have the following properties you can pass, and they're configurable everywhere. To the degree where if I do an X build UI, same properties. I can play around with them if I want to, right? And that's one good thing. So I can say, build things. There you go. I can also test things, right? Again, here you go. It's cool. So I could do that without having to worry about how to configure all of this, right? So our Next, in this case, manages the configuration for SWC and the type check and everything correctly. It manages the configuration for jest, for lint, right? So if I want to focus on my application, my system, and not worry too much about how jest should be configured, right? As jest evolves, especially as it changes, right? Relying on the plugin is a good deal. So it's basically like a fancy npm script, like a typed npm script that is optimized for Monorepo workflows. Right? By the way, one thing I want to show you, you can see this test, right? Let me run it again, right? No, this time it's retrieved from cache. But I want you to pay attention that even though everything here, it actually didn't run, was retrieved from cache, as you can see at the same time. But it looks exactly the same, right? The colors, and everything. And it's because the way we capture terminal output to replay it is different from any other tool. We actually monkey patch node itself to capture it truly as is. So when you retrieve something from cache and we print the terminal output for you, it's always printed like as if you just ran it, right? With everything being correct, right? So that's a plugin. So it's cool because, it's handy, it's right there. I can click on things, it runs, right? It autocompletes, so I cannot, screw it up and stuff, right? But there are other advantages, right? One of the advantages is that we have a command called migrate, which I don't have time to talk about right now, right? But if I do something like a next migrate latest, Next is going to look at every plugin you have in your package.json, right? It will look at, for example, Naro.js, Naro linter, Naro jest. It will find the latest versions of those, right? And it's going to see how to update your workspace to work with latest versions. So it's going to install the latest versions of Jest and ESLint and whatever you need, SWC. And it's going to update your workspace's configuration and source files to make sure they work with latest. Right? That's why I think it's much cooler. Where for one of the things that we did, for example, let's use ESLint now. We used to have a TSLint. I think we still have actually executor that you can use to run TSLint. TSLint is deprecated, or like end of life basically, shouldn't be used. A lot of large workspaces, large companies did use TSLint. So with this migration thing that we had, we could move them automatically, like where 98% of the work was done for them by our migration scripts, so they could switch from TSLint to ESLint and preserve the behavior basically as is with some minor variations. And they could do it like in a day. Something that would have been impossible, period. They would have forever stuck with TSLint, right, if it wasn't for Next, right? So a lot of folks who use Next tend to be up to date with NextJS, Angular, Cypresses, Storybooks, with all this stuff, because we make the act of upgrading to latest like much cheaper, right? An order of magnitude cheaper. Another thing I want to tell you that folks don't usually talk about, right, is that one of the things that I think is problematic with monorepos, the way when folks use Yarn workspaces to do monorepos, is that the developer experience usually sucks, right? And it sucks because if I go inside here, this is my remix app, importing the component, header component, and if I go to definition, note, I'm in a dist folder and I look at the GTS file, right? So this is what I want. I want to consume the compiled version of components when I build it, but when I'm in the editor, when I click in here, I actually want to see this thing over here. Right? I want to see this. The fact that I don't see this is a problem because refactorings don't work, navigations don't work. It basically sucks, okay? And that is a big deal, right? Much bigger deal than folks realize at first, right? When you could of course fix it yourself through the magic of custom scripting and stuff, right? But when you use our plugins for things like that, or for React, for Webpack, for NextJS, we take care of it automatically, where we would always point to source in the editor, but during build, our plugins would like substitute resolves and stuff to consume stuff from dist, so you kind of get the best of both worlds. Developers in your editor will only look at source, and the build process will look at dist. Right? Okay, so that's the plugin stuff. Let me show you something else. Let me also check it in and say, more progress. What I'm going to show you now is I'm going to invoke Next generate and a CI workflow. Okay, so this is perhaps the one of the cooler parts of Next that most folks don't realize, because if you haven't worked at Google or Uber or whatever, right, you would never know that is impossible. Right? I'm going to generate a CI config using GitHub Actions, but you can pick a different. You can also create your own. This is simply an affordance to make it a bit easier. Right? Okay, let's take a look. Ooh, okay, so a bunch of random garbage appeared. Man, hide it. Okay, cool. So what happened in here? We have a GitHub Actions config, and what does it do? It does two things, right? It sets up a set of agents, And agents basically are machines that are going to do most of the work, right, of the CI. And has a main job. And in the main job, it says, oh, I'd like to run a few things in parallel. Oh, I would like to run these three things. All links, all tests, and all builds in parallel and across multiple agents, basically on these machines. By the way, I can change this number. I get 50. 50 sounds crazy to you. Not crazy. Some of our clients have that many agents running every single CI, I think, because they have big monorepos. Right? Monorepos can be big. The only thing to do when you have a big monorepo is to distribute. Right? So if you do this, that is the whole CI config you need to have a distributed, cacheable, basically scale, like really horizontally scalable CI setup, right? For repo of pretty much any size, right? This is the same CI config you could have to build a repo with 2,000 projects, right? It would look about the same, right? And you can also, by the way, publish things over here. Right? And this is the beauty of an NX cloud, right? Why? Remember I talked about this invariance? Things like that matter because those things enable distribution, right? Because of those invariants, when I run this build thing and one agent starts building components over here, the other two agents over here will have nothing to do because Next and Remix app cannot be built while components are being built, right? There's dependency in there, right? The invariant for Next and Remix app cannot be met until components are built. So what are these going to do, the other two agents? Going to start doing these things. One of them will start linting, another one will start testing. Once the components are done building, right, what is going to happen? Some agents are going to pick up the next app build, and some other agents are going to pick up the Remix app build, right? So all of this, and the one that picks up the next app build may not be the one that has built components prior, right? So what it's going to do is going to say, hey, I have this invariant thing, and the next cloud in this case is going to be like, oh, because we have this invariant, I'm going to get the artifacts, this folder basically, from whatever agent built the component and move it to you such that you can build the next app. And the same stuff with Remix, right? That happens absolutely transparently. You don't have to do anything to make this happen. Nothing, right? The files will be moved about. All this work will happen behind the scenes, and you get an illusion, or like an impression, like the way your CI will look like, the way a command will look like, if this will run on a single machine. Let me show you. I mean, I could submit this particular PR, but the NX repo does basically the same thing, and it has a lot more, like there's a lot more going on in there, right? So look, this is the NX repo itself. NX, as I mentioned, is built with NX, right? So it ran a bunch of things in here, right? In parallel, etc. It's very cool. Let me run this build. All the build things are all in here, all in one place, as if it all happened, on one machine, even though it happened across many machines. So that's sort of a real repo that does real things, and it's actually, oh shoot, and it, what is it? So the command actually does things, and there's a lot more going on. So what I'm going to do now is I'm going to push more work in progress. Push this repo to just show you that it magically works, right? Okay, so I have this now, right? So I'm going to create a example, my PR, let's say, right? And again, I'm going to open a header. We're going to change some stuff, right? Test commit, push origin my PR. And now let me do this. And, okay. We just need to wait now a few minutes till this whole thing happens. And you will see this thing appearing here in the cart. So while this is happening, let me show you why this matters. So why do we need to distribute, right? Because some folks can say, well, I have distributed caching. Why, or like, why is caching good enough? Well, the issue with caching is that caching is useful for many things, but it can only reduce the average CI time. It cannot help with the worst case CI time, right? Which kind of makes sense. Like on average, you wouldn't, like some things will be cached, so the average CI time will go down. But you have large PRs in your repo. Sometimes you have PRs that change everything in your repo. So no matter how cool you are at caching, right, or how good you are fact is to knowing only what to rebuild, really being smart in general, using the effect of caching, is only helpful for the average case scenario. The worst case scenario, which is everything has changed, being smart is no use, can only be helped with distribution, right? And that's why, right? So we are interested not just in making the average case better. If we want to guarantee that your CI time takes, let's say, 15 minutes, cannot take longer than this, it's 15 minutes or faster, you have to distribute. And if you have graphs like this built, where components have to be built before other things, and this is big enough graph, let's say with like even like a few dozen packages, you have to distribute intelligently by using something like this, right? You either have to create your own system, which will likely be hard to create. This is a very hard problem, right? Caching is a trivial problem. Distribution is a hard problem, right? So you have to have distribution really in practice for any sizable repo, right? You have to distribute in some fashion. Most companies do it ad hoc. They do batch and binning, where they split text in 2 buckets or whatever. They have 1 agent that build. They have 3 agents that test. That creates a gazillion of problems, and I'm going to show you. Oh, the CI failed. Okay. Okay, what has happened in here? All right. So the CI have happened. I screwed up a few things. For example, my workspace didn't have any test tools, except the shared package, and there's just a bunch of things that I didn't think through. But you can see the CI has completed. The build is here, and the components remixed app and next app have all been built. I can see the result over here. They've been built on separate machines. But if I go to, say, my main job, right, and I look at the result, right, you'll see that all the logs are in one place, and all the files are in one place on the main agent. That's everything I wanted to show you today. If you think it's interesting, check out NextJS. There are lots of cool docs in there, lots of examples, just a lot of information for basically everyone, right? Regardless of what your level of expertise is, you should be able to find something to help you get started. If you have any feedback, please, let us know. Ping me on Twitter, go to community Slack. Just basically share your feedback. We're interested in making the Next better, easy to understand, do more cool things, scale better. So the more you talk to us, the easier it is for us to do it, right? And thank you so much.